All right, so you got this homework assignment tonight, W1.10, and then also 1.12. But 1.12 we talked about. 1.10, let's go through this. What do we mean? No formulas. No Formula One either. On your reference table, there are equations that address each of these questions then. So let's see if we can pull it up for a second. There are equations here on PRT6 that actually address those exact questions, but I don't want you worried about those yet because we haven't really learned physics yet. What we have learned is manipulation of units, and that's how I want you to do this. That's why we say no formulae, no formulas, and no Formula One allowed because we're not looking at PRT6 for this page. No PRT6. On the back, different. But page one, none of that. So how do we sort this out? You're doing dimensional analysis here. You're only looking at the units. So Omar drives at a speed of 5 meters per second for 20 seconds. What I want you to worry about are the units only. Meters per second, seconds. What do we do? Write them down. M over S. I don't want any of this nonsense. Get rid of that. M over S. Okay? S. Now, with those two alone, we've detached the units from the magnitude. We're only looking at the units. We now say, let's look at our four answer choices. They are all in the unit meter. Is there a way that we can combine meter per second and second such that it results in meter? Well, the answer is yes. In fact, it's quite simple. The way to do it here is just to multiply. If you multiply these two, then the seconds will cancel and you are left with meters. Now, why is that something that helps us for this problem? Because realizing that the math with the units requires multiplication allows you then to back up. Let's get this out of the way for a minute. Allows you then to back up and tap the numbers in. There was a 5 attached to meters per second. There was a 20 attached to seconds. We said multiply, and then that will actually give us our answer. So the seconds cancel. 5 times 20 is 100. Boom, there's our answer. Done. That's how this gets done. So all of these are going to be the same exact process. Here's one. I'll start you on it, and then you take it over. Question 2, 10 coulombs per second. By the way, coulomb is a capital C. Blah, 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 100 coulombs. Fine. So if we write these down here, you have coulomb per second. And then this other one, we have coulomb. And somehow these two need to be combined to result in, all four answer choices are seconds. So it somehow has to result in seconds. Well, how could we do it? You can try it with multiplication. Does that work? Well, if you multiply these two, you would get C times C. You get coulombs squared over seconds. Nope, that does not work. So multiplication is not going to be the way you get this one. What's the other options? Division. Question is, which do you divide? So we can try, let's see, I'll bring it over here. We can try coulomb per second divided by coulomb. Does that do it? When we keep change flip, you get coulomb per second times 1 over coulomb. If you did this, the coulombs cancel, you get 1 over seconds. Nope, that does not match. That is not our method. We're not going to use that. So the only other option is coulomb divide coulomb per second. Keep change flip. So coulomb times, flip this to second over coulomb. Oh, that might be something. Anyway, that's how this all works. So you're doing 5 questions like that. On the back is actually easier. Let's go real quick. Fundamental, you know how to do all this. 6, 7, 8, just read it. 9. Down here for 10, 11, 12, 13. You are finding the units by looking at the equations. Now we actually want PRT6. Now we actually want your reference table. So actually I provided you everything you need right here. I believe. No, I provided you only a segment. You're actually going to need your full reference table for this. So your full reference table, page 6, looks like this. And of course the page goes all the way down. So you're going to need some of these equations over here. Anyway, back over. Let's look at the example because the other 3 you're going to do on your own. The example here is V. Well, what is V? If you go look on your reference table, V stands for, down here in the bottom right, velocity or speed. And more importantly, what is the equation for V? The equation for V is right here. V or V bar. Now V is speed or velocity. V bar, that little bar on top, is average velocity or average speed. So speed and average speed, or velocity and average velocity, they have the same unit. And we are concerned about the unit, so it doesn't matter if this is an average in the equation. Speed and average speed are the same. What's your speed? 50 miles per hour. What was your average speed? 38 miles per hour. It's still the same unit. Now let's go back over here. You need the unit for speed. Now miles per hour is not going to be it because that's not SI. We need SI in terms of kilograms, meters, and seconds. So how do we get it? We look at the equation for speed. Here is that equation. The equation is d over t. D divide t. Now you know what d is and you know what t is. D is distance, t is time. You know the unit for d, the meter. You know the unit for time, the second. So just follow the math. If speed is equivalent to distance divided time, then the units for speed is equivalent to the unit for distance divided the unit for time. So the unit for distance over the unit for time is the meter per second. There's your answer. The other three you'll have to do with the same exact process. When I say second one over here, I mean this second equation of PRT6. This is the 12th, this is the 20th. This is not difficult, but your answers over here are only allowed to have kilograms, meters, seconds. Doesn't have to have all three. Those are the only three that are possible. All right.